Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today, we're taking a deep dive into a trending project on GitHub, Heretic, a tool that automatically removes censorship from language models. With nearly 900 new stars today alone, this Python-based project addresses one of the most debated aspects of modern AI, the built-in restrictions that limit what these models can discuss or generate. It's a controversial but technically fascinating solution that's clearly resonating with developers who want unrestricted access to AI capabilities. A project launched just 3 days ago has already racked up over 6,000 stars on GitHub. So, what's the technical magic behind this phenomenon? Meet Heretic, a tool promising to fully automate what used to be a labor-intensive, expert-only task, removing censorship from large language models. Heretic, developed by PEW, has accumulated 6,440 stars on GitHub, with 891 added just today. This Python-based tool implements what researchers call directional ablation, also known as obliteration. That's a technique for stripping away the safety alignment mechanisms that make language models refuse certain prompts. What sets Heretic apart from previous implementations is its promise of complete automation. Where earlier tools required deep knowledge of transformer architecture and careful manual tuning, Heretic needs only a single command. Specify a model name from Hugging Face, and the system handles everything else. Behind this simplicity lies a sophisticated optimization framework powered by Optuna, automatically searching for parameters that balance removing refusals while preserving the model's original capabilities. The problem Heretic addresses sits at a fascinating intersection of AI safety and capability. Language models undergo safety alignment, a training process that teaches them to refuse requests deemed harmful, unethical, or illegal. While this alignment serves important purposes, it also creates limitations. Researchers studying model internals, developers building specialized applications, or users requiring uncensored responses for legitimate purposes face a dilemma. Removing this alignment manually requires identifying specific neural pathways responsible for refusal behavior, computing refusal direction vectors across model layers, and carefully ablating these directions without destroying the model's intelligence. This process demands expertise in transformer internals, access to significant computational resources, and hours of trial and error parameter tuning. Previous tools automated parts of this workflow, but still required human judgment to select layers, directions, and ablation strengths. The fundamental limitation was clear. Removing model censorship remained an expert-only task, inaccessible to most researchers and developers who could benefit from it. Heretic's core innovation lies in how it parameterizes the ablation process and automates the search for optimal parameters. Traditional obliteration identifies refusal directions by computing the difference between model hidden states when processing harmful versus harmless prompts, then orthogonalizes certain weight matrices to inhibit these directions. Heretic extends this with several key advances. First, it introduces a floating point direction index. Instead of choosing one discrete refusal direction from a specific layer, Heretic can linearly interpolate between directions from adjacent layers. This creates a continuous space of possible intervention vectors, massively expanding the search space and often finding better directions than any single layer provides. Second, Heretic uses a flexible ablation weight kernel. Rather than applying constant intervention strength across all layers, it defines a parameterized kernel shape controlled by maximum weight, position, minimum weight, and distance parameters. Think of it as a surgical scalpel with adjustable blade pressure rather than a sledgehammer. The system can apply strong interventions where refusal circuits concentrate while leaving other layers relatively untouched. Third, and most crucially, Heretic frames parameter selection as an optimization problem. Using Optuna's tree-structured parse and estimator algorithm, it searches this parameter space to co-minimize two objectives: refusal rate on harmful prompts, and KL Divergence from the original model on harmless prompts. This dual-objective optimization ensures thorough censorship removal while maximizing intelligence preservation. The system even performs automatic hardware benchmarking at startup to determine optimal batch sizes, making full use of available resources. Heretic targets 3 primary user groups. AI researchers studying model internals can use it to generate uncensored base models for experiments without spending days on manual ablation. The tool includes research features like residual vector visualization and geometric analysis specifically for interpretability studies. Developers building specialized applications, perhaps content moderation systems that need to process potentially harmful text, or creative writing assistants that shouldn't refuse edgy fiction prompts, can deploy locally hosted uncensored models tailored to their use cases. The AI enthusiast community has already created over 1,000 Heretic processed models on Hugging Face, demonstrating strong grassroots adoption. Entry barrier is remarkably low. Install Python 3.10 or higher. Ensure PyTorch 2.2 or higher is configured for your hardware. Then, run a single command specifying your target model. The process is fully automatic. No configuration required, though advanced users can customize parameters via command line flags or TOML files. Processing time varies by model size. On an RTX 3090, decensoring Llama 3.18b instruct takes about 45 minutes with default settings. For users with limited VRAM, Heretic supports 4-bit quantization via bitsand bytes, drastically reducing memory requirements and making even large model processing feasible on consumer hardware. The community reception has been notably enthusiastic. Reddit discussions highlight practical impact. One user commented that Heretic GPT OSS 20b provides properly formatted long responses to sensitive topics using uncensored language while maintaining markdown tables and detailed outputs, calling it the best obliterated version yet. Another praised Heretic GPT 20b as the best uncensored model they've tried, noting it doesn't destroy intelligence and answers prompts normally rejected by base models. A third user, running on 16 GB VRAM, found Quen34b instruct 2507 Heretic, the best unquantized obliterated model they could execute. These testimonials emphasize 2 recurring themes: preservation of model capabilities alongside thorough refusal removal and accessibility even on limited hardware. The project has already spawned a Discord community with over 1,000 members and maintains an active Hugging Face organization showcasing curated examples. However, no significant negative reviews or concerns are documented in the available data, which might reflect either early-stage adoption or selection bias in community feedback channels. Despite impressive results, several considerations warrant examination. Heretic's effectiveness depends heavily on the harmful and harmless prompt datasets used for computing refusal directions and evaluation. If these datasets lack diversity or carry biases, the resulting models may only perform well on tested examples while still refusing other sensitive topics or suffering degraded capabilities elsewhere. This is the overfitting problem in a different guise. For truly massive models, those exceeding 100 billion parameters, the optimization process involving multiple model evaluations remains computationally expensive even with quantization, potentially requiring days and limiting practical applicability at the largest scales. The project explicitly doesn't support state space models, hybrid architectures, models with inhomogeneous layers, or certain novel attention mechanisms. As language model architecture innovation accelerates, maintaining compatibility will require continuous updates to identify and handle new component types in emerging architectures. There's also a measurement limitation. While KL Divergence effectively quantifies output distribution changes, it doesn't fully capture all aspects of model intelligence like complex reasoning, code generation quality, or creative capabilities. The ablation process might damage these higher-order abilities in ways that don't significantly impact KL Divergence, creating hidden quality degradation not reflected in the optimization metrics. Heretic democratizes access to uncensored language models by automating what was previously an expert-only task, delivering results that rival or exceed manually tuned obliterations. For researchers studying model internals, developers needing specialized deployments, and AI enthusiasts exploring model capabilities, This represents a significant leap in accessibility. The project matters because it transforms censorship removal from a niche expertise into a single command line tool, while maintaining the quality and intelligence preservation that manual approaches struggle to achieve.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.